This show is supported by our beautiful members on Patreon, which might include you.
Ooh.
Get to the ad break to hear more and learn how to join. This is Cup of Go for May 31st, 2024. I'm back.
Hi, Shai.
Keep up to date with the important happenings in the Go community in about 15 minutes per week. I'm Shai Nechmad.
I'm Jonathan Hall.
Miki, thanks a lot for covering for me last week. I appreciate it. It was a really good episode.
All right. Let's pound through a couple of quick news items before we talk about something a little more interesting. Pre-release announcement. You know how this goes. 122.4 and 121.11 will be released on Tuesday. We'll tell you more next week.
Secret security fixes?
It is.
Nice.
Couple meetups to mention. Both are actually kind of, the two we have on the list here, unless you know of others, Shai, are kind of related to me. So I'll be speaking at the Atlanta Go meetup on June 12th, 7 p.m. in Atlanta. If you're in that area, come by. It's the same meetup that Bill Kennedy spoke at last month. So I guess they're doing a international tour or something. I don't know. Bill Kennedy's, I guess, not international, but he's from a different state. The other one is just announced. There's a new Go meetup here in the Netherlands that's happening on June 20 in Tilburg. I would be so tempted to go. It's an hour, 15-minute drive for me, but I'll be meeting my co-host Shai in person that night, I think, or is it the night before?
So it's the night before.
It's the night before. Maybe I can go. Maybe I can go.
So many meetups.
So yeah, those are the two meetups. No more details there because that only affect a small percentage of our listeners.
Even though it affects a small percentage of listeners, I do want to remind everyone that on June 19th, we're planning a Cup of Go meetup. It's basically just a chance for Jonathan and I to meet, but we did want to open it to other folks if they want to join. Currently planning just beers and perhaps a short live recording, even if it's just for fun, going through the news items inside a bar instead of the comfort of our homes.
Yeah.
So June 19th in Amsterdam. If you can make it, it would be really, really cool. Also, if you have an office to lend to us. So we have an update on a past proposal, which we discussed. I think it's very, there's not a lot of drama about it, right? It's very, everybody agrees it's good. It's exactly what we added generics for, which is map functions that are generic in the standard library, both inserting, reading, looking at the lists and whatever. And unlike our usual links here, which are links to issues, this is a link to Gerrit, which can only mean one thing.
It's been not only accepted, but it's actually been implemented.
Yeah, that happens as well.
Yeah. So I have to say, I'm honestly looking forward to this new iterator. As much as I dislike the Seek and Seek 2 naming, and I think it's kind of a complicated implementation, I'm looking forward to using it, which will help, I think, reduce the number of things that you shouldn't use Go for, which I think might be an interesting topic. Maybe somebody should bring it up on Reddit.
Yeah, so following a similar thread in Rust, people are like, oh, I really like Go, but what isn't it a good fit for? I think this is actually super important knowledge, especially if you're more junior-ish, like if you're in the beginning of your journey and you fell in love with Go. It's really important to know where to not use it. So you could seriously bring it up as a trade-off at work or wherever, for yourself when you need to write a piece of software. I've really come to the realization that there isn't a one language beats all. It's a very childish discussion to be like, what's the best language? It does matter personally what languages you like using. Like I like using Go, and I also have invested a lot of time into it. So I have sunk cost into it, which isn't, at this point, it's not a fallacy. I can write Go a lot faster than other languages, but it's important to know where it's not a good fit, right? If you can do something in a super short 2-line shell script and you're never going to change it, maybe it's fine to just do it in a shell script, not like, all right, let's open Cobra, Viper, OS, whatever. And there's a thread on Reddit here by Accurate Peak 4856. Great names as usual on Reddit with some, genuine answers that I liked. The first one is highlighting that since Go is garbage collected, hard real-time processing is not a great fit. Mm-hmm. I tried to find the best application that wouldn't be a good fit, if that makes sense, like the best worst application. Some people mentioned the audio. Yeah. Like you wouldn't write effects for, virtual guitar amplification software like Guitar Rig in Go. But when I hear like hard real-time processes, I also imagine things like flight computers and things like that, right? Trains.
I suppose, yeah. I don't know. I don't work in that space. I mean, my feeling is that audio in computer terms is pretty slow. I mean, 44 kilohertz or whatever isn't that fast. We have embedded chips that run at like 2 megahertz that can handle that sort of stuff. So it doesn't strike me as like an obvious problem space, but maybe it is. I don't know. I don't work in that space.
So I tried implementing guitar effects because this is was sad, but I had the free version of Guitar Rig, which only came with a few effects when I was 18 or whatever. And I tried to develop my own effect and add it as a VST plugin into the Guitar Rig software because I couldn't buy the effects because I didn't have a credit card. So like I could afford it. I just didn't know how to go through the process of buying stuff on the internet. And it's very difficult to actually, even if the like actual signal rate is very low, you have to be pretty good to write stuff that doesn't immediately go like,
yeah.
At least that's my experience.
So one of the takes that I could resonate with, it just says simply, Excel macros should not be written in Go. And I agree with that because Excel macros just shouldn't be written. Just don't use Excel.
Spreadsheet is running the world, man. Like it or hate it. One thing I saw that was, we brought up here on the show with a good friend, Andy Williams, maybe GUIs. A small tool, maybe this is it's a potential convert to Fine. I call them a pre-Fine developer. They say maybe GUIs, a small tool, maybe, but a serious project. I don't think I've seen a good-looking GUI app in Go. So I tend to agree and disagree. I think it's possible if you really care about having your application written in Go, you could make it beautiful with Fine. But if you just want to get GUI out the door, unfortunately, the best way to do it today is just write a web app and ship Electron, which sucks for the users, right? Because they have like half a gig of memory for, you showing your to-do app or whatever. Mm-hmm. But it's just the most cross-platform, whatever way. And you can rewrite it in Go once you have 1 million users, right? But I don't know. Maybe I'm thinking about this backwards and actually starting with Go makes more sense because it'll keep the UI very simple. I don't know.
Yeah, I don't know. I think one last comment I want to call out here to kind of counter these arguments against using Go for everything. One person says he even wrote his wedding vows in Go. So
yeah, someone in great Reddit etiquette, someone wrote, "I write everything in Go," and then someone responded, "That comment is not a valid Go syntax." So unlike usual Reddit hate that I spew here, I really like this thread. I think it's interesting. There's interesting discussions here, and I'm gonna foreshadow our interview. There's one comment here that says probably AI related stuff, which is better in Python. Mm-hmm. So stick around to our interview to find out if that's actually true.
Ooh.
So yeah, cool Reddit thread. The link is it's pretty fresh, right? It's like a few days ago. So the link is in the show notes if you want to go and nerd out about what Go is and isn't good for. The flame wars that way. Good luck.
So here's one that was brought up on our Slack channel. Thanks, Arno, for shouting this out. The title of the blog post is Blazingly Fast Shadow Stacks for Go. I don't know what a shadow stack is, but it sounds creepy.
Isn't blazingly fast, specifically stored for Rust blog post? I thought we weren't allowed to use those in garbage collected languages. So what's this blog post about? The graph at the top seems very interesting.
Yeah, so it shows a line chart with 2 lines, a blue line that goes up to the right, as you would expect on a line chart, and a red line that's almost horizontal, I should say, near the bottom. The TLDR, I'll just read it because it's short and I think it does a good summary. Software shadow stacks could deliver up to 8x faster stack trace capturing in the Go runtime when compared to the frame pointer unwinding that landed in Go 1.21. This doesn't mean that this idea should escape from the laboratory right away, but it offers a fun glimpse into a potential future of hardware accelerated stack trace capturing via shadow stacks.
So just to give some context, the author of this article, which via the TLDR sounds like, what they did in Go 121 is just stupid. There's 8x performance. He's the person who wrote the 121 implementation. So it's all good.
He's crapping on his own backyard or whatever.
So it sounds very interesting, but what are shadow stacks? Other than sounding super, super, super cool. Sounds like, I don't know, sounds like some ninja futuristic. It could be the next cyberpunk game, right? Cyberpunk 2078 Shadow Stacks. So other than a cool name for a futuristic video game, what does it actually mean?
I'm trying to learn that right now.
I tried to give you some time.
I know. I got halfway there while you were segueing there. Maybe before we talk about what shadow stacks are, we can talk about the problem. So if you want to generate a stack trace in Go, it's kind of an expensive operation, which is, by the way, why they're not included in errors by default. Mm-hmm. Way back in Go 1.13, when they added error wrapping and unwrapping, I believe they even implemented including stack traces in all Go errors, and it slowed things down so much they had to take it out. I don't know if it was actually merged, but they definitely tried it, and it was too slow, so they took it out. So my hope is that maybe this will allow us to put that back in. But to build that stack trace is an expensive process because you have to sort of go through every stack frame and figure out which line of code was related to it and all this and so on and so forth. TLDR, a shadow stack kind of maintains that on the fly as the stack is popped and pushed and as you run through your code. So as you call a new function, it keeps the shadow stack up to date with what's already happening in a much less expensive way so that it doesn't have to be done in a slow way. That's a really redundant thing to say there.
The reason this is like a new thing, it's not a new algorithm, right? It's access to modern hardware.
Right.
So it's still kind of new, and you'll probably never interface it with it from user space, just writing code, right? But if the language could utilize these, and you have these new CPUs running on your web servers or wherever you're running your Go program, you could decide. I imagine a future, a year from now, where you have Go debug equals shadow stack tracing equals 1. If you care about the error stacks and the performance isn't critical for you, so you could accept that trade-off, right? Every error having a full stack trace. If you care more about reliability and I guess observability than pure performance.
Mm-hmm.
I actually imagine it being like, okay, for 10% of my users or 10% of my servers, I ship, with stack traces. For the other 10%, I ship with a profile turned on, right, for profile guided optimizations. Mm-hmm. And then the rest, 80%, are the normal ones where it's like release mode with all the optimizations built in and none of the extra observability or debugging features inside. And then all the premier users, we promise they're always going to the good servers. Could really help you strike a good balance between all these developer-facing features, better error handling and profile guide optimizations and whatever, and just trying to eke out the best performance you can from the language.
At the end of the article, he also talks about doing the shadow stack in software. That has some drawbacks. It hurts performance for certain cases while improving for others. So it's not a clear win. But maybe by adding the support for the hardware shadow stack, we can get some performance improvements.
Yeah. I think this is a really fascinating article. I actually tried to read it a few times, and it's a very technical article, not easy.
It's not that long, but it kind of jumps in the deep end quickly.
So we just gave you the cliff notes of this. But if you really want to understand this further, there are a few links inside here, and it's really well written. By the way, another like very personal blog that I like. This is not like on Medium or whatever. This is just Felix's personal blog. I'm not going to say the last name. No way. I'm going to put the link to the blog post, but also just the blog itself in the show notes, because the blog itself is really cool. Has a few blog posts, and I'm really hoping to see more in the future. No pressure. Talking about a cool blog post, there's one last blog post I really want to talk about, just because it's cool. I want to nerd out about it. It's less about the Go language, but more about Go's infrastructure. And it's named Abusing Go's Infrastructure, which is already kind of interesting. So Go has a checksum database. Do you know what that is?
Vaguely. I don't know the details of how it works, but it keeps track of of all of the revisions of public modules, right?
Public Go modules, right?
Yeah, right.
So no. This assumption you just had is the assumption of everybody who used this database. And the security researcher in this blog post shares how you can upload any arbitrary data into this server, and not just Go models. It doesn't filter on it having any Go code whatsoever, having a Go mod file. So as an attacker, you could say, okay, if I want to take the Go checksum database down, maybe I can just start uploading infinite amounts of random data as packages. So that's not true. The Go authors did have DDoSing in mind, or just DOSing. Sorry.
So to be clear, it does store version information for Go modules, but it also stores arbitrary other stuff. Is that what you're saying?
By accident, you can upload other packages there as well.
Okay.
The intention, the happy path intention, is to store Go related metadata, so you can, when you go mod and go sum, it has the hashes, right? That's how it works. But you don't need to specify anything specific in the repo you were uploading to put it in the Go checksum database. The Go authors realized that this could lead to DOS, so there's a limit, right? There's a limit on the package size. There's a limit on the Go mod file size, like half a gig and 16 megabyte or things like that. But you can bypass download restrictions on developer machines. You could, if you're malware, you could store payloads and retrieve them from that server. And, it's not like you're storing your malware on I'm a hacker this is a bad website.xyz. When you look at web firewalls and things like that, around your organization, you're going to see network traffic to go to some database. It's going to look totally legit, at least from the domain, right? So it's a very interesting, the DOS is going to be very challenging to execute, but if you're writing malware, it's a really good free hosting for you that looks really nice. This is not that problematic, in my opinion, to operate a command and control server from legit servers. Is something that almost any development, file storage, shared whatever software has an issue with. So Go is not unique here. But I was surprised to see it in Go as well. You can basically do a request for the model path, you parse the result, extract the version, you make another request to download the zip file, and you have the zip file. This is a very, very simple way to implement commands from these command and control server hosted by the Go team, right? By accident. So a really cool security, sort of red team, white hat approach to Go's infrastructure.
Yeah.
Also written in a way I really like. It's like, okay, I went to sleep, I woke up, I still need answers. This is this is really an approach that I like. So really good blog post. Reverse engineer, again, by the way, another good blog, personal blog. So 2 personal blog community things posted. We're going to put, again, both links in the show notes. I don't think that there's any reason for alarm in terms of, oh my God, this is like a very serious vulnerability that puts anyone in danger. Not really. It's interesting, but I don't think it's major. Hello.
So my son has just walked into the room to end the recording. You want to say hi, Harvey?
Hi.
Hi. I guess this is a good time to go to our ad break.
I think it means it's time for me to be a papa again. So we'll end the recording here, and we'll see you at the other side of the ad break with an interview with Riccardo.
Yeah, we have a very interesting interview coming up.
Let me help you.
Yes, an interview. Are we recording?
We are. We're live.
Welcome to our ad break. We're not live. This is a podcast.
We're live right now as we record. Previously live, as every recording ever possible.
Live at the time. Welcome to our ad break. I don't know if Filippo kept all that in. If you want to sponsor the show and help us with this fun but yet expensive hobby, you can join as a member on Patreon. We want to thank all our existing Patreons and our new member, Simon Law, for helping support the show. This money just goes towards editing fees, hosting fees, stuff like that. It might pay for the beer in Amsterdam, but the flight is paid for by my company, so don't worry about it. I'm not flying on airplanes on your dime.
Right.
If you want to reach us, the best way to do it is cupago.dev. You can find links to all important show-related things there. I don't know if important. This show is not important. It's just
not
like cozy
important.
and fun. Yeah. You can find the store there where you can hook yourself up with some cool swag.
That is
hoodies.
important, I have to say. The swag is important.
We do it for the swag. And the same reason everybody was in RSA last week, just for the swag. You can find links to our Slack channel where there's a ton of interesting discussion recently. Hashtag Cupago on the Gophers Slack. And you can email us at news@cupago.dev. That is news@cupago.dev. If you want to support the show in other ways, the best way to do it is through word of mouth. We don't pay to advertise or promote the show at all. All the great audience participation, engagement, and just numbers we're seeing are just thanks to y'all sharing the show, talking about it, And on that note, we really want to say thanks to Pavel. I got notified on LinkedIn, which doesn't happen a lot. You're a LinkedIn beast, right? You troll a lot. So I
love
don't
to
really
troll.
engage with that platform too much. But I got pinged by Pavel, and I don't know. How did you feel when you read this post?
Good. I mean, it's a fairly long post. We won't read the whole thing. I like the tagline. Unpopular opinion: the first book you read when learning a new language should be about writing tests.
100%.
And I think I agree with that. And then he talks about being introduced to. Did he say that we introduced him to Go, or he just started?
He began his
show?
journey in Golang with the Cup of Go podcast.
Yeah, so that's good to hear.
Yeah.
And he enjoyed the episode where we interviewed Adelina Simeon about her book, Test-Driven Development in Go. So, it's nice to see that the show is having an impact on people. Can I say this? I'm not going to share names, but you mentioned before we recorded today that one of our previous guests got some VC funding as a result of coming on our show.
Yeah.
So that feels good, too, to just be having an impact and helping people with their careers and learning Go and everything.
Yeah, we set up this show to just learn Go ourselves and make sure we're on top of everything new in Go. So it was a very selfish endeavor, as you would imagine recording yourself on a weekly basis is. But it turned out to be, the community and the talking to people about it turned out to be a much bigger part for me than the personal angle, I would say. So thanks a lot, Pavel, for your unpopular opinion. If your other unpopular opinions can also include liking us, that would be good. And it will also track with what I normally know about myself, that it's unpopular to like me. So if you want to help support the show, you know how to do it. If you want to get more Cup of Go in your life, physical or in your ears, cupofgo.dev is where you do it. And one last thing before we send you off to our very interesting interview. We plan to do a physical episode. We mentioned this on the show as well. June 19th in Amsterdam. If you can make it, please tell us. And if not, totally fine. John and I will just slam a couple of beers.
Could just be two of us. It'll probably be a lower quality episode if it's just the two of us than if somebody joins us. But we'll make it happen.
Fun. Stick around for an interview with Riccardo about Hugo. It's going to be interesting.
Hugo? Isn't that a static site web generator?
Let's find out. Hey, Jonathan.
Hi, Shai.
All right. So I really want to set us up here. I really like blogging, static blogging. So today we're talking about Hugo. It's a project in Go called Hugo. And that's what I know, right?
Yeah. I think you spelled that wrong.
What do you mean?
Hugo has a T at the end.
Doesn't sound like it.
Well, maybe we could find someone to explain why it's spelled that way. Hey, Riccardo, could you help us with that?
Yes, I can. Hey, yeah, it's, there's the famous dictum that says there's only two hard things in computer science: hash validation and naming things. And I think this might be unfortunately a result of that because Hugo is not the Hugo static website, the stuff that we know and love, but it is something completely different. It is a library that we've been building for machine learning in Go. Actually, transformers in Go.
That sounds even more exciting than static websites.
Well, it depends what you like, but it is very exciting, definitely.
All right, well, let's talk about that. But first, Riccardo, would you tell us a little bit about who you are, and then we'll talk about the project.
Yeah, so I'm Riccardo Pinosio. I am a machine learning engineer, and I currently work at Knights Analytics, and which is a company that builds essentially solution for master data management. And before that, I was working at various companies, mostly as a machine learning engineer in the AI and finance space. And before that, also, I did my PhD here in Amsterdam in mathematical logic. So I actually mathematical logician by training. And I've been using Go. I'm actually quite a recent convert to Go because it's been slightly more than 2 years using Go. Before that, of course, coming from machine learning and AI, it was essentially, first R, and then Python, lots of Python everywhere, obviously. But then when I started working at the Knight, we built our product called Alchemia. The whole stack is built in Go, right? And one of the goals was to integrate more and more machine learning capabilities and transformer capabilities into the product. And that's actually where Hugo comes from. And that's essentially what the origin, right, of Hugo. That's what I've been doing in the past years. We need transformers and machine learning capabilities in our Alchemia product because we all work a lot also with structured data and NLP and mastering that type of unstructured and semi-structured data.
Okay.
And therefore we use a lot of the latest techniques for that. But it wasn't that easy to do it in Go, obviously, because it's not. I think it's still a bit behind with respect to, let's say, Python in terms of machine learning. But my hope is that it will get better, and there's a lot of opportunity to make it better. Right? So that's also fun.
Hugo calls itself a hugging face transformer pipeline in Golang, or pipelines in Golang is the description of it. For those of us in the audience, including myself, who don't really know machine learning, what is Hugging Face, and why would you want a Golang pipeline for it?
Yeah, I can explain that. So essentially, Hugging Face is, let's say, the most important repository of machine learning models, of open source machine learning models that is out there. So what they do is they try to let's say, market themselves as, let's say, the GitHub. So the goal is, as a researcher or as a company that builds a machine learning model, you can publish your models on Hugging Face. And they have a variety of models there, right? From, let's say, image classification. The classic example is this image picture of a cat or a dog, to natural language processing, which might be tasks like, if I have a sentence, can you identify, let's say, whether this sentence has a positive or negative sentiment?
Yeah, I really like the example in the README where you have two sentences which sound obviously, positive and negative when you read them out loud. The positive one is, this movie is disgustingly good.
Yeah, exactly.
The negative one is, the director tried too much. But when you actually think about what these sentences say, like the words in them, so the first one has the word disgusting in it, so maybe it's negative. And the director tried a lot, maybe it's good. So to humans, it's obvious, that the labels are correct. And then the model obviously, labels them correctly as well with a really high confidence score. I think it's a really good README example, slightly more interesting than the dog cat example.
yeah, exactly. Because there's a bit of subtlety there, right? The ability of a model to be able to pick up on the things that you pointed out is not trivial. And so Hugging Face is essentially a repository for all of like this type of models. I mean, they have like many, right? From simple to very advanced, many applications, computer vision, natural language processing, multimodal, LLMs, all sorts of things. But it's not just that. It's also a collection of open source libraries. The most famous one is called Transformers. And it's written it's a Python library. And what it offers is essentially a nice interface, a nice library to train transformer models, so train this type of models, and also perform inference with them. So use them to predict. So you might use the transformers library from Hugging Face to, let's say, take a model that has already been trained, like the example that Shay was giving. Right? So I already have a model to classify whether a sentence is positive or negative, and I want to do inference with it on a set of 1 million sentences that I have. And you might use that library to be able to do that. Or you might have a set of sentences that you already classified as positive or negative yourself, right? With old school manual labor of looking at the sentences and say, yeah, this is positive or this is negative. And then you might use the Hugging Face Transformer library to train your models. That's called, let's say, fine-tuning. That's how we call it in technical terms. Fine-tuning basically means you already have a model that has been trained, but you now have additional training data. You want that model to look at that training data and get better at the task, right? And so Hugging Face Transformers offers all of these capabilities. The issue, of course, that we encountered in our case is that that's all Python based. They do have some Rust actually, but basically the main way of doing this is through Python. So we rapidly encountered the technical issue of, well, if I train my model with transformer libraries to classify sentences, how do I then run it in my Golang application at scale, and then being able to make use of all of the nice things that Go gives us, right? In terms of concurrency and so on and so forth, and speed. That's where Hugo sort of came from, because we didn't find any solution that sort of really fit our purpose there.
So clearly Python is in the lead, so to speak, as far as like a number of libraries and just general community support and so on for machine learning and all sorts of data transformations and stuff like that.
So I'm going to stop you right there.
Yeah.
I just had this argument at work.
Okay.
It seems like Python is in the lead, but in reality, C is in the lead, because every single important Python library that you use for machine learning is just a wrapper around C right now, right? It's not like you're using PyTorch and
But nobody's writing, well, not nobody, but few people are writing C to do this work. They're writing Python. I mean, you could say the same about any interpreted language. You could say JavaScript isn't in the lead in the browser because it's all written in C. I mean,
yeah, but there are many libraries that are pure JavaScript that you could get into. But if you want to get into, the model or anything like that, it's not like you have a better vantage point. For example, trying to compare two models, doing it from Python than doing it from any other language. It's just the libraries right now are written in Python. So I agree, but it's important to because it's so dominant, it's important to remember that it's not like inherently there's something in Python that makes it good for machine learning. It's just easy to get and to get started and write like simple scripts.
Right. I don't think that changes my point though, because I mean, if I'm not mistaken, even Hugo uses a lot of C bindings.
Yeah, that's very much true. So essentially, I think you're kind of both right in a way, in the sense that Python is, it's true that most of the machine learning libraries are essentially calling into C, because for obvious reasons, in the sense that machine learning inference is a very expensive operation, and training is even worse. So every sort of inch of performance that you can have there is worthwhile. And obviously Python is not known as the most performant language of all. And so then that is how it is. However, Python does have a strength in that sense, because it's extremely easy to write bindings to C code and even to Rust code from Python, right? So it's kind of like that scenario of like a language that is very much very good at writing. It's very good to write wrappers around C code or Rust code and so on and so forth. And so in that sense, it's not very different from Bash, right? I mean, I think there is like a strength, maybe with the Blast I'm saying, but actually there is a similarity, parallel there, right? I mean, but Bash is also very good at calling into C, compile, routines and so on and so forth. And that's essentially how Python is used there. So PyTorch is C, C++ in the background, and so on and so forth. And that's also what we do in Go. And Go is a bit more challenging because of Go, but that's also the route we went down, because we thought, well, essentially you kind of have two options, right? You have to either you build something in native Go, or you essentially rely on bindings to what is already there in C and write around it all sorts of functionalities and make it easy to use. Yeah. And there have been attempts, right? If you look at Go packages, there are Go packages that try to do these things in native Go at various levels of, let's say, abstraction, from writing your own neural network to being able to run pre-trained models. But though that presents a lot of challenges, because it's very hard. These are very big projects, right? They're very hard to write. They need a lot of effort to maintain. They're large community effort, and you always run the risk, essentially, not being able to maintain such a large project. For us, it was an easier path, and I think we also think more fruitful path, to align ourselves with Onyx Runtime. Probably for the listeners, they don't know what that is. It's a Microsoft project. Onyx stands for Open Neural Network Exchange. It's a format, actually. It's basically like a file format to store this type of models, machine learning models. But they also provide C APIs to be able to run these models at scale. It's very optimized, very fast. And so what Hugo does is essentially use the bindings, right, to the Onyx C API to be able to read these models and then run inference with the models, and also post-process the output so that it's usable and can be easily used by a Go developer to replicate essentially exactly what the Python version does. So the goal was really, for us, was really, hey, if I test something with Python transformers, Hugging Face, which is sort of state of the art, the standard, the industry standard for open source transformers. I ran something there. I see the results. How can I do this now? How can I take that model and transfer it to Go and run it in pure Go? In our Go application, but without having to call into Python or do the other hacky things. So that's essentially what the goal of allow the Hugo library. Yeah.
So I have a couple of questions. I want to get back to the question I was going to ask regarding when I started the preamble of Python seems to be sort of in the lead, at least in terms of code written to integrate or to do machine learning and data analytics. Most of the data scientists and data engineers are writing Python code.
Yeah.
What other languages? I mean, I know it's one of your goals to sort of help Go rise to that level. Maybe even, if all our wildest dreams come true, supplant Python, become the leading language in that space. But what are the other languages? I know R is popular in there. I don't know if it really is in the same space as Python. You talked about Rust. What other languages, if we frame this as a competition, what other languages is Go up against in this race?
So I would say definitely, so Python is currently definitely at the top, right? It's the lead, that's without question. R is very strong in the traditional statistical tooling, right? Statistical models. But for the latest things, all AI now is, well, not all AI, I should say, but a lot of AI, a lot of attention, right? It's on generative AI and transformers and the GPT stuff and all that kind of stuff. For that is very much behind compared to Python. Because the community, for a programming language are community efforts in the end. So of course the community influences very much what the language is used for, right? So R is very much the prominent language for statisticians. And so the functionalities implemented there are all statistical functionality and classical machine learning. But then for transformers and AI, it's very much behind. Python has the strength of being the glue, right? So obviously it's on the top. I do think we'll see a resurgence of actually C and C++ themselves, as in even skipping the Python layer and just directly straight using C and C++ to build your ML applications. Then there's obviously Rust, which has some advantages. I think it's more advanced than Go currently in that space. For example, Hugging Face tokenizers, which is a fundamental component of Hugging Face transformers, is written in Rust, and then you have Python bindings to it, right? But Python makes it really easy to bind to Rust, right? And so that's basically how that works. So I think these are definitely the main contenders. There's Julia. I haven't used Julia very much, to be honest. I'm not sure how it's doing on the generative AI transformers kind of battlefield.
The last time I heard about Julia is when there was a theoretical discussion about programming languages similar to this one. We're like, we're wondering what languages might be relevant for X. I have yet to see it. Anyone who gets paid money and talk to me about it. And I tend to talk to a lot of programmers. So I wouldn't be too worried about Julia. If you're listening and you're like, oh my God, I have to learn Julia as well. You can put it at the bottom of the backlog, I think.
Yeah, the only thing I know about Julia that, of course, makes me very happy as a nerd is that you can actually write Greek letters in your program, right? So you can use full Unicode. So your variables can be alpha and gamma and so on and so forth.
Killer feature.
And of course, you would never want to do that, right? I mean, it's a terrible idea in practice, I think, but hey, it looks really nice if I'm writing a math algorithm and I can put alpha as it was, right? And also makes you feel very smart. So these are always a good idea.
Yeah, well, you can do the same in Go if you really want to. By the way, it supports full Unicode variable names too. Yeah.
Okay. Then
so if you want to do that terrible thing,
I'm going to go back and rewrite our old code base with alpha, beta, gamma, and then I'm just going to push it without code review, and then I'm going to see what happens.
That's awesome.
You're going to see the stargazers. You know how in GitHub you have the stargazers shot and always going up. You're going to start to see it go down.
See the crash.
So Hugo is the main thing you need to learn, or the main thing you need to know to use it, other than Golang, of course, is pipelines, right? The concept of pipelines in Hugging Face, which is not the concept of pipelines is not specific to Hugo. It's just something you need to learn if you're using Hugging Face, which is basically pick the model you want to work with for whatever task, and then start to run it. How much did you want to stick to the Python pipeline API, which seems very open and you can like do whatever you want? There are 5 different ways to open a pipeline. They're all valid. If I know and already use the Python Hugging Face SDK, like will my migration be super easy? And I just need to, I copy paste the pipeline code and just replace the equals with our, colon equals and everything going to work? Or is it a very different API with like different intentions in mind?
No, so the goal of what we have done there now is essentially to be a one-to-one rendition of what is on the Python side. So the goal was really, so first of all, just to explain what a pipeline is, because maybe it's like, so there's a bit of a difference between a model and the pipeline in the sense that the model is just a neural network, right? And the output of the output of the neural network is essentially an array, right? Or a slice of arrays, right? So it's all flow.
I don't remember where I heard it, but I just heard it this morning that linear algebra had the biggest marketing scheme ever, rebranding as AI.
Oh, yes, very much so, yes. Indeed. If it's a linear algebra, you think of it as the most boring thing in the world, but now if you say like it's AI, then it's... No, but that's very true. So it's all.
Yeah, I don't know if Elon would raise 6 billion for X linear algebra, but X AI for sure. Just take my money.
X matrix multiplication. That doesn't sound good enough. So it's all matrix multiplication, right? In the end, there. So the output of the model is just a big matrix. Yeah. But of course, if you have a specific use case, like for example, a thing we do a lot is I have a sentence and I need to extract what we call named entities from the sentence. So, for example, if I have the sentence, Sam Altman is the CEO of OpenAI. Sam Altman is an entity of type individual. CEO is an entity of type role, and OpenAI is an entity of type organization. Yeah, the model, if I ran it on the sentence, will just give me the matrix, but then I need to reshape it. I need to look at the labels. I need to do some sort of bunch of post-processing to get, as a result, a JSON that tells me, hey, these are the entities that are in there, right? So that's what's happening, by the way, also on the transformers side, right? So the Python transformers pipelines from Hugging Face are running on PyTorch, right? The model is a PyTorch thing, and then they have this sort of class that wraps around it and does all of these nice things for you so that you don't have to worry about implementing all of it yourself. You can just pass in a sentence and get a JSON out. That's the idea. And the idea of Hugo is that currently is that we replicate that functionality we don't have all pipelines. Actually, this is a good call. If you want to contribute, there's still a lot of work to do. We don't have all the pipelines that Hugging Face supports implemented. We have like a set of core ones for NLP, because that's also what we use in Ninth Analytics. But if you want to contribute, we are very much open for people to come over and help us integrate further pipelines in the library. But essentially, it aims to match that one-to-one. Yes. The only thing I will mention there, or caveat, is that we only support, and for the foreseeable future, we will only support runtime exports of the equivalent Hugging Face model, right? So the typical flow for you as a developer, if you want to use it, is you can try it in Python, you can try the pipeline in Python, see if it gives the results that you want. Then you can use an Hugging Face to export the model into Onyx runtime. It basically exports it into a folder with like a couple of files and with the Onyx binary format. And then you go to Hugo and you essentially point it to that folder. And then you can recreate that same pipeline in Go and run the model.
Cool. So a pretty easy migration from if I'm working in Python today.
Yes.
What benefits have you seen in Nights Analytics from doing this project in Go? Obviously, all three of us here are biased. We probably wouldn't be hosting the podcast, and you probably wouldn't be a guest if we didn't like the language. But, trying to look at it objectively, it sounds like you start experimenting with Python, then you migrate to Go, but you migrated to Go, and then what? Like, what's the benefits you've seen specifically, where you work?
So for us, it was essentially a matter of, so a lot of the things that we do, for example, are deploy. So our old stack is Go, right? And Go offers us benefits in terms of concurrency, being able to ingest and concurrent and very easily design concurrent systems and we wanted to be able to, for example, take 1 million or like 10 million or whatever, 100 million of news articles and just pipe them through these models, right? To be able to extract information from them. Yeah. And Go, of course, makes that extremely effective compared to Python to design that type of concurrency model. The additional problem we had was that we could not do API calls because we deploy it in environments where you're not allowed to send any data outside, right? For instance.
Mm-hmm.
So we needed to do this at scale and locally, right? Without doing HTTP REST calls to whatever. And so that was sort of like the setup, right? The benefit for us to be able to do this in Go is the ability of concurrently pipe input to these models at scale, and with Hugo you can do it. There's no API calls, so you can do it locally, right, with a local model, and that's essentially the setting, right, that we were trying to tackle. We are actually in the process. I don't have data for that yet, but one thing that I have actually this is also a good issue for a first timer who wants to contribute is to compare the performance with the Python version. So if I take a Python pipeline and like with the Hugo version, I can go, what is the performance gain or the performance difference between the two implementations? So that's one thing that we're looking at. But for us, actually, the pure performance was less important in this case as also the stability and the ability of sort of have a tight integration with our larger Go application.
So, like, maintainability within your current ecosystem was a big thing.
Yeah, because imagine, I mean, if you're like, let's say, and we have this use case, right? So there are people that are using Go for like this scenario. You have a Go application, and you want to it receives, let's say, a call like an API call that sends with post, let's say, some news article. And you want to be able to calculate an embedding of the news article and find similar articles. That's a typical use case. We call it semantic search. It basically means take some text, create a vector from that text, and then use that vector to find similar articles, for example, similar news articles from a database of articles that you have already previously embedded. Yeah. And if you want to do that in Go, let's say without Hugo, what you'd have to do is you would have to say, okay, well, I have my backend in Go, but now I need to be able to call a transformer models to get this embedding vectors out. How do I do it? Well, you could have a Python microservice that you would deploy separately, and then you could do an API call to that Python microservice that would send back the response with the embedding, and then you could, do whatever search you want to do. But then this complicates things, right? So now suddenly, if your application is Go, you need the Python microservice, which will need to have its own container deployment, for example, which will have to have its own. So it introduces a whole host of complexity versus being able to do it with Hugo, which is, hey, I have this folder on S3. It has the model. Use the Hugo library to load it in. Now it's your struct in memory with your struct method to do inference, and you just pass it in, right? So it becomes a much easier story to maintain, build, manage. If your Go application, if you have a Go application, right, and you want to use these machine learning capabilities.
I can really imagine someone on their way to work right now, just being like angry because they just yesterday finished deploying their new Python backend.
Yeah.
Because they thought, oh, it's machine learning, I have to do it in Python, and then they're just listening and they're like, Shai, how do you know my life?
Yeah,
Coming
exactly.
into
Yeah,
work and like,
and we have people, right? That we talk to that are using Hugo that said like, oh, now I have all my Python microservices. I'm going to start migrating them all back to, I'm going to start
yeah.
all removing them and then use Hugo, so I can do it in one whole.
One last question. I hope it's a quick one. We need to wrap up soon. Suppose somebody listening is interested in machine learning. They've never done it before, but they know Go. What's the learning curve like to just jump right in with Hugo instead of learning it with Python first? Is that tenable, or is that going to be a really steep learning curve?
I think it's doable to just go straight to Hugo because, again, if you don't want to understand the underlying details, the concept is not super difficult. You just need to understand what's your use case, right? If I know what my use case is, hey, I want to be able to do sentiment analysis or extraction. You can go look at the Hugo documentation. You can see, well, is there a pipeline that can help me here that has been already implemented? And then the only thing that you would have to do is, and that for that you still need Python, although I'm hoping to eventually being able to do it without it, is you would need to find a model in Hugging Face that you want to use, right? That is already pre-trained, for instance. And then you would have to export it to the Onyx format that we use. But that's literally like 5 lines. From Optimum, which is the Hugging Face library, import Onyx runtime, and then you load the model in, and then you export it to Onyx. So it's like 5 lines of Python. And then what that does is generate a folder with all the assets that you need. And then you can use it with Hugo. So I think that the learning curve to be able to do inference with models that are already trained is very low.
Okay.
If you want to train your model, meaning you want to fine tune it, then at the moment you can't do that with Hugo. You still need to go via Python. So we only do inference. However, I'm hoping to also fix that because I'm currently working on having the bindings to the Onyx runtime training. So if I can get that done, which is the C library for Onyx runtime that allows you to train models. So if I can get those bindings going, then eventually you'll be able to use Hugo also to train your model. So provide it with examples, provide the model with examples, and then fine tune it. And then you have a better model. So that you don't have to go to Python at all. That would be the dream, right?
Yeah, right.
So that's that. But for the moment, if you want to do inference, I think you can start with, and you have a use case for which you want to do a model, use a model. You can start straight with Hugo. Yeah.
Great. Well, let's tell people where they can find you and Hugo. Hugo's on GitHub. Is there a website other than that, or is GitHub the best place to go?
Yeah, that's the best place to go for now. We have you just go to GitHub. We have a README that I think it's quite comprehensive, and I'm working on a docs page and actually a tutorial.
Please tell me the docs page for Hugo is going to be in Hugo. and then my joke from the beginning will be complete.
Now that I didn't think about it, but actually that's a great idea. Hugo on Hugo, and then it's like Hugo Inception or
yeah.
Yes, indeed. So that will be there. And I'm working also on a tutorial for semantic search with Hugo and Quadrant, which is a vector database. I'm not sure you guys heard of it, but it's a very good vector database. And so, but for the moment, if people want to learn more and contribute, the GitHub Hugo page is perfect. The README is quite extensive, I think. And yeah, and we look forward to people using it, contributing to it.
And if people want to reach out to you specifically, where can you be found online?
I think I'm not really that much of a social media person or this kind of stuff. I'm not.
That's good.
It's a lot of waste.
I'm happy to hear that.
It's a lot of waste of time. I think actually, if it's on Hugo, you can just use the issues page on GitHub. Otherwise, you can send me an email, which is you can also go to the Nice Analytics webpage and contact us through there. So if you Google.
If you're listening, the link is in both for the GitHub and for nightanalytics.com is in the show notes.
Yep.
Yeah.
So you can jump on there.
Yeah, exactly. If you go to the Nights Analytics. Yeah.
We have one last question that we like to ask all of our guests. This might be easier for you since you said you just started using Go about a couple of years ago.
Yeah.
But the question is, thinking all the way back to when you started learning Go, what surprised you the most, or what was the biggest challenge for you?
Okay, yeah, that's a good question that I always like answering, because I really like programming languages and I like to talk about their differences, and I like to bitch about them and tell what and also say what I like.
Good.
It's like the gossip. It's like the nerd version of gossiping, right? So
Yes.
I
Yes.
would say let's do some gossip. So the thing that I like, the thing that I find most challenging, I think, when I started Lingo was, as a machine learning engineer, I mostly work with extremely expressive languages, right? Like, so Python, R is actually basically a Lisp version. Well, it's very close to Lisp, so it's extremely expressive. Python, you can do all your classes, inheritance, all the object-oriented programming, so on and so forth. Go, when I started, the type system is quite bare, right? It's quite bare bones. And so I did have quite a lot of struggle to switch the mindset from, before I used to think, okay, let's think about what types we have, right? So, or what classes we have, and let's structure the code base thinking about the types and the classes and and the methods that they have and what they are able to do and how they interact with each other and so on and so forth. And then moving to Go, I missed that type of abstraction, because I really do think Go works best when you just write code, almost in an imperative fashion, and then you introduce abstractions as you go, when you need them and where you need them. So I found that's the thing I found most challenging, like the type system, the lack of the lack of enums, the lack of union types, discriminative union types. I think
Right.
those were sort of challenging. But now that I use it a bit more, I don't miss that much, because you really need to get into that mindset of let's do abstractions later on as they arise, versus let's try to plan all my abstractions and how I'm going to do it. I also found that Go, for me, it's a very good language in a way for my productivity, because I do tend to I have the tendency, I think, to sometimes over engineer things, just because I like the abstraction, right? It's just like, oh, I have this class. Oh, I can do some.
We're all guilty of it one time or
I can
another.
do the smart reflection thing here and save, and then it's all, yeah, you know what I mean? And then Go tells me like, no, you're going to abstract. You're going to have a for loop. And if you want something, you can have the interface, and that's that. And I noticed actually that, in the end, I'm actually much more productive in Go.
Sort of reins in your creativity to the important parts.
Yes, yeah, exactly. Exactly. That's. I think it's like I think it's like, if you had a metaphor, Go is like, sort of like a Greek temple, right? So it's clean, and the lines are all straight lines, and it's sort of like, versus, okay, the super complication of types and so on and so forth. So that's I think the what I like about Go. And in a way, it feels very similar to C, right? So right now I'm writing bindings to C, and I get kind of the same feeling, right, from C, which is like, yeah, let's not just get bogged into too much abstraction that then I look at them like in 2 months and I don't know what I'm doing there, because I thought I was clever at the time, and and now it's like, hey, what the? You see what I'm saying? I think everybody has that experience, and I think that's what's nice about Go. And the other one, which I think is also the one that everybody mentions because it was in the Stack Overflow survey, is the error handling. If error not equal to null, to nil, do this other thing.
Yeah.
And so that is actually the single thing that I think it would be really nice to have, like return types and option types, like Rust does it. I think the way Rust does it there is strictly better, but it's a small thing. I mean,
we saw recently a few articles. I don't remember the name of, like, a language that compiles to Go. Do you remember what I'm talking about?
Borgo.
Borgo, I think it's called.
Yeah.
Borgo, yeah.
Obviously, it's very experimental and early, but it sounds like exactly the your kind of your cup of tea, where it's in Go, but you have return types, and it's in the middle between complexity and type safety.
Yes, exactly.
Trying to have its cake and eat it too. It's a result type, so the value is the cake, and the error is oops, I ate it. It returns both.
Yes, it's funny you mentioned that because I was thinking the other day, it would be really nice if Rust and Go had a child that was a bit less smart than Rust sometimes, and a bit more smart than Go sometimes another day. And Borgo is kind of thing that's the idea, right? Because you can, if I remember correctly, you can write and you have option and return types, but then it compiles indeed to Go. So it feels almost like
it transpiles to Go, but yeah,
indeed,
totally. Well, thanks a lot, Riccardo, for jumping on our machine learning adventure, which is not normal for us. Like people on this call usually are like, okay, so this is the 500th web server I've written, and this is what I think about it.
Yeah.
But yeah, there are other aspects to Go as well that are expanding. Again, the call to action from this, if you listen to this podcast and you were like, oh my God, this sounds super interesting, the link for this GitHub repo is in the show notes, and there's a very obvious path to contributing. There are many missing pipelines.
Yes, exactly.
So if you have a pipeline that you currently have and Hugo supports, great. You can use Go and machine learning. Awesome. And if the pipeline isn't supported yet, just from a quick browse of the repo, it seems like a very easy, open source swag you can carry. It's not very difficult to add another transform in the current, add another pipeline, in the current architecture.
No, and we're there, and we're very supportive for anybody that wants to contribute. I mean, the goal is to make machine learning in Go a thing, so that we can use Go not only or to write the 500th web server or to do cloud deployments or all of that backend stuff, but also to integrate tightly with machine learning capabilities. So any contribution is welcome.
Cool. So thanks a lot.
Thanks again.
Thank you.